So today I'm going to be talking a little bit on multi-layer test automation approach, cutting across all the layers of the application, and why is it required, and how are we going to go about it. Um, my name is Srini Sankar. I manage the digital testing practice at Aspire Systems, and I'm based out of Dallas, Texas, in the US. Let's get started. So the agenda for today, like I said, we're going to talk about the multi-layered test automation approach and um, what exactly that is and why is it required and how are we going to go about achieving that. And I'm going to demonstrate or walk through a real life case study for one of the projects that we did for a customer of ours, a large lifestyle retailer here in the US. And we're going to see how that helped make a difference in their overall delivery and the quality objectives that they had. Before we get started, I just wanted to quickly showcase this. This is a regular defect summary. Please do take a look at this. It just says that the payment confirmation page is not displayed after the payment is submitted. This is a straightforward defect summary that we see day in and day out. Just tells what the problem is. Nothing uneventful about this, or nothing eventful about this. But when you compare this with what a multi-layered test automation approach could produce as a defect summary or a defect description, you would be able to note the difference here. The one on the left is the one that we saw in the previous slide. Payment confirmation page is not displayed after the payment is submitted. But when you have a multi-layered automation approach, your defect summary or your defect description, it's going to look like this. The third-party payments API is taking more than 3 minutes time to respond. And that is causing a timeout, which is in turn resulting that payment is not going through and the payment confirmation page is not displayed. If you look at this, there are multiple layers of the application that are being investigated and are reported here. The first part here is that the API is being tested as well, not just the UI. And the responsiveness of the API is tested as well, which is the performance of the that API in scope. And we noticed that it's the responsiveness of that API that's causing this issue, which is why the payments are not going through. When you have this kind of a defect description, then that's going to help your developers to dig right into the issue without doing much of a taking much time to do research on where the problem is going to be. And this does cut down your overall turnaround time for getting your defect fixes. And this is exactly the kind of benefit a multi-layered testing approach could bring into the table. Now, let's take a look at what this means from a concept perspective. So we call this as hyper testing at Aspire. This is a term that we coined in-house. So as a hyper test, as you're talking about hyper testing, it's a unified approach to looking at quality, right? If you're a if your application is a consumer web application or a consumer mobile app, and it's open in the internet, it doesn't matter what kind of an issue the application has, be it a functional issue or a application performance or responsiveness or a security vulnerability. Your end users are not going to be bothered by what kind of issue it is. All they care about is that if it is working fine or not, and if there are issues, they're going to tweet about it and spread the news in the social media. So we wanted to have an approach that replicates the user behavior or the user perspective, and we wanted to look at quality as a whole, not as a functional quality or a non-functional quality. So in order to look at quality as a whole, your testing approach needs to be an integrated approach as well, that test all layers of the application, the UI, the APIs, and then some of the non-functional aspects of the application as well, like the performance of the application, of the security vulnerabilities that are there in the application. So all these has to be tested as part of a single strategy. And to enable this, we need to take the help of the technology to come up with an automation solution that could take care of all these from a single automation framework or a single set of functions or methods. And that's what this hyper testing is all about. It's the perspective to look at quality as a whole and not piecemeal as functional or non-functional. And let me quickly talk about where in real case, in a real world scenario, this applied as a use case and how this was implemented, what are the different components of the framework that was built for this particular company, and how it helped at the end of the day. So they were a large American departmental store, and they were undertaking a journey of digital transformation. And they had four key objectives. First one, they wanted to release features faster to market. Um, Before this initiative started, their release cycle was staggered to quarterly releases, but then they had emergency monthly releases as well. But that was not going to cut out when making a digital transformation initiative, and they wanted to reduce it to a bi-monthly release with a 2 week sprint. So for that to happen, there's a lot that needs to be pushed from a process perspective for the testing team as well as the development team. I'll talk a little bit on that in the upcoming slides. And the second objective was to reduce the defect leakage as much as possible, because previously the defect leakage across all their other projects was about 14 to 20%, somewhere within that range. And they had a mandate to reduce it or bring it down to under 3%. And the third objective was to provide a seamless user experience across different browsers and mobile devices. Being a consumer web portal, the e-commerce platform had to uh, provide a fantastic user experience or consistent user experience across all the browsers and devices through which the end users are going to access the application. And then the fourth point was the application performance or responsiveness. So they wanted to have the standard industry best practices in terms of having very low response time, or I should say very high response time for their application performance, so that users don't get to see page load delays and all that stuff. So these are the four main objectives that the organization set for us. And when we went in and did a bit of analysis, we also found that there are a couple of impediments in achieving these specific goals. One of that was when we had to do the testing number to over 3,000 cases. Well, the total number of test cases that were there in the system was about 500. But when you have to pick and choose the test cases that need to be executed cross-browser across more than 10 browsers and device combinations, then the number ballooned to over 3,000 test cases. And so, which means that for every 2 weeks, 3,000 test cases had to be run, which is not a simple enough task. And at that point in time, they did not have any automation in place as well. And it took about 20 business days for every release to complete one cycle of testing with multiple people. So the total number of days that the testing happened was more than 45, and it was close to about 60 days. That had to be drastically cut down to make sure that the whole testing was completed within the 2 week sprint. And they had multiple different APIs that were integrating to the system, like the payment platform, and then there was a cataloging service and a couple of other services that were integrating to this new system. And of course, there were no performance tests or security assessments that were done in detail before. So these were some of the impediments when we began this digital transformation journey. And to offset these impediments, we had to look at an innovative approach where the whole strategy, or like I said, the whole perspective has to be quality as a whole, not just functional and non-functional. And towards this, we were pretty clear that it has to be a process level change. And to support that process level change, we had to take the help of technology. And of course, to enforce that technology adoptions, then we need to have people that are multi-skilled. So from a process standpoint, it was an integrated testing strategy, the hyper testing model that I talked about, where we wanted to focus on quality as a whole. When we provided reports or defect summaries or defect descriptions, it has to have exact place where the problem is and help cut down the overall turnaround time for fixing those issues. And we also wanted to make sure that as testers, we wanted to get involved right at the early stage of the product lifecycle or the project lifecycle, right from the requirements phase. By that way, we could build quality into the product or rather than waiting for the build to come to us and then do the testing, we wanted to get our hands on the requirement document, make sure that the requirements are accurate and complete, and act as a quality gate right at that stage, and then do the same for design documents from the development teams and so on and so forth. So we wanted to have a quality engineering approach rather than a quality assurance approach. And then the third process that we wanted implemented was sprint plus one model, which is basically to balance manual testing and test automation. We were very clear that manual testing cannot be done away with, and test automation is not a replacement for manual testing. Test automation could only be a complementary aspect to manual testing, and we wanted to have a right balance between manual and test automation. So to enforce these processes, we had to take the help of technology. It's not just that when you have manual testers doing functional testing of the UI, APIs, and all that, you need to have an integrated automation approach that takes care of this as well. So we came up with a unified automation approach that took care of the UI, the APIs, did performance testing, did security vulnerability assessment as well. And the whole framework setup had to be scalable because at that point in time, they were not ready for a DevOps or a CI/CD model. But then they were on the way to moving towards that, and we wanted to make sure that whatever automation that we created was able to scale up to that level. And of course, the main benefit of or the main advantage of test automation is to run parallel tests and reduce your overall testing cycle time. And these were the four different components that we took care of when we built the technology aspect of it. And of course, to build this, we had to have people that are multi-skilled. We have SDETs who basically have the ability to do functional testing, test automation, and a bit of non-functional testing. So that really helped in getting this put together. So let me talk a little bit on the technology part, which was the key or the cornerstone of the overall, the hyper testing process. So here are the framework components that we built in. We use Selenium as the code. And before I get into that, let me just quickly highlight that whatever solutioning that we were going to put in, we wanted to take the help of open source technologies because we wanted to make sure that the technology and the infrastructure cost is pretty low and are kept to a minimum so that the customers could benefit on that on the cost perspective. So we went ahead with our automation using Selenium WebDriver. We used the standard page object model way of design, highly reusable scripts. But then, in addition to the functional aspects of the Selenium automation, we also integrated a couple of non-functional testing tools as well. One such tool was OWASP-Zap, which is the open source tool for scanning your application for the top 10 security vulnerabilities. This is an open source tool. We integrated with our framework so that whenever a build is deployed, when we kickstart our test automation, the smoke test pack or the end-to-end test pack, the OWASP Zap is going to be triggered and it's going to scan the application for vulnerabilities as well. As a standard best practice, we have seen that the security and the penetration testing happens after the UAT, after all the testing is done, only at the last stage before go live. That may still be the case, but we still wanted to identify at a high level the basic vulnerabilities in the earliest stage of the product or the project lifecycle. And that's the reason we integrated this OWASP Zap. And it started providing results on some of the vulnerabilities right from the initial days of testing. So that way, the quality was built in right from day one rather than waiting till the end. And I got to make it clear that this is not a replacement for your detailed penetration testing, but this is only a security vulnerability assessment. At a high level, that's what it is. And then we also had multiple different APIs that need to be tested. So we integrated SOAP UI. We also did integration to Rest Assured, but SOAP UI was a primary tool that we integrated. And we use SOAP UI for two purposes. One is to validate the APIs that are integrating to the application and make sure that there is nothing breaking in the API side of things. And then the second point was to use the SOAP UI or the APIs to generate the test data for our testing. So as UI test, like I said, we had about 3,000 test cases that need to be executed. And for performance test, that number was even going to be higher because we are running concurrent users on the system over a period of time. So there was a lot of need for test data that needs to be generated. You had to have customers already included in the system, and there needs to be product catalogs in the system, and all these different things. So when we initially began, we started generating UI-based automation scripts to populate the test data in the system, and that took forever to do that. So we went ahead and used SOAP UI to generate the test data in the backend, and that really cut down the test data generation time. Whatever that took a couple of days earlier with a UI-based data generation, through SOAP UI, it took about a couple of minutes to get all the data there in the backend, and that really helped with overall, your our testing time frame as well. And then we also deliberated on using the same Selenium script for running the performance test. We are not really successful with that. So we went ahead and integrated JMeter as the performance testing tool to the overall setup. Not to confuse that, this is not reusing any of the Selenium components. This is just standalone JMeter, but we have integrated in the overall setup so that all these tests could be triggered simultaneously. When your functional test is triggered, you could also trigger your JMeter baseline test and then the benchmark test, so that for every build, all these tests are run as and when the build is deployed. And then we also had an integration to Gallon framework, which is a framework to test the application layouts in the web. I know there are tools that are much better at doing this, like the Sauce Lab Screener or Apply tools. But we wanted to use something open source, and we just went with the basic version of the layout verification tool, which is the Gallon framework. It's open source, could be integrated with any Selenium project. And this basically works by comparing the CSS files and verifying if the screen resolutions and all that is not, making the layouts haphazard. That's what we used, and that was quite decent. I wouldn't say that this would be as good as Apply tools or Sauce Screener, but did help us at the basic level. And then the other set of tools that we integrated were APM and Vinium. APM for running the test in mobile devices, both hybrid as well as native applications, and then Vinium for running the test on, some of the legacy desktop applications when we are running end-to-end test on the system. So both were successful. We didn't use APM much because it was a responsive web application. Selenium was able to get the job done, but we did have APM at a high level to just be scalable when in case the company wants to move towards native app. And then when we had all this set up, we also wanted to have an environment where we could run parallel tests. And since there were cross-browser testing that was required, we had to go with multiple different versions of the browsers and multiple different mobile devices and tablets as well. So our choice of the testing environment was Sauce Labs. We had a couple of different concurrent licenses that we had purchased and used this to run all our tests over the cloud. And the overall setup also integrated with Jenkins, which was the CI/CD tool for that particular organization. And we made sure that all the test scripts and the framework is all integrated to Jenkins. So this at a high level were the framework components that we built in to do integrated or the wholesome testing strategy that covered across multiple different layers of the application product. If you look at this, except for pretty much Sauce Labs, pretty much everything is open source. We did not pay for any of these tools, and that includes SOAP UI as well. We had SOAP UI, the base version for running the test, and we used Rest Assured to some extent as well. So here's a quick diagram on the test automation framework, how all these different tools were integrated together. So we had the core of the system, which is the Selenium core, and we isolated the test data separately so that if there is any need to change the data or update the data, you don't have to go and update any of your automation scripts. You could just update your test data, while your automation code could reside in a version controlled environment. And we had a separate configuration files for running the test in different environments and using the different environment variables. And this whole setup had integrations with different tools like Selenium, Vimium, and APM for catering different platforms such as web, desktop, and mobile applications. And if you look at the bottom panel, these are the non-functional tool integrations. We had JMeter, WebZap, SOAP UI, REST Assured, and Gallon. But we also had Cucumber, but as a feature that was on standby, but we did not really use behavior-driven model for this particular project. And this whole framework setup does integrate with the CI/CD and runs the test over the cloud. And when you get your test results, it's not just going to be a functional test result, but it's also going to have your API web service test results, your performance test results, and security testing results. We also understand that reporting is a key aspect of any testing, and we integrated machine learning based auto analysis reporting, and this is from a tool called Report Portal. It's a free for use tool. You could go to their website reportportal.io and integrate your Selenium projects. The advantage of using this tool is that there are two things. One is the tool, with the help of the machine learning algorithm, it's going to auto-analyze your test results. So you have 3,000 tests that are running, and there may be about 5 to 10% of failures. Let's say if you have 150 cases that fail for every release, and not all of them could be due to product bugs. That could be script level issues or data issues, or the environment might have gone down and that may have caused issues. But however, as a tester, you may have to go and review all of these 150 failures to see if it's a product defect or not. That is obviously going to take a lot of time. But when we use this report portal, it's going to analyze your test results and categorize the failure according to the type of failure it is. So it's going to classify your failure as a product bug or an environment issue or a data issue or a script issue, whatever it is. And it's going to do this by continuous learning. Of course, for the first one or two builds of testing, you got to manually mark what kind of failure it is. And the algorithm is going to learn from it and going to auto-analyze your test results. So this cut down a lot of our test analysis time and also help to focus on those that are categorized as product defects as the go-to areas whenever we get the test results. So that was the first advantage of this tool. And the second advantage was is the reporting that the tool provided in terms of giving trend analysis, where you could see a trend on what are the flaky tests, the tests that are passing and failing between different builds, and the tests that are continuously failing, and what are the requirements that are vulnerable to failure. So you get to take much more actionable. You get much more actionable metrics to take effective decisions, not just total number of passed, total failed, and the regular metrics, but you also get a trend analysis to see what test cases are continuously failing, which ones are flaky, and all those different stuff. So that really helped with the decision making with this tool. All right. So that's on the technology side of things. And on the process perspective, like I said, we had to find a right balance between manual testing and test automation. And we had to go with an approach called a sprint plus one approach. And in this approach, for any particular sprint, we wanted to make sure that all new features that are being rolled out are tested manually at least once. And only when that particular feature is certified stable by the manual testing team, the automation team would take those features and automate them. So typically how it happens is in a particular sprint, the manual testing team gets the build, tests the new features, and then once they are certified okay, then the test cases that were created by the manual team is passed on to the automation team. And the automation team will start automating that in the subsequent sprint and use the automated test cases for regression testing in the subsequent sprint. So at any particular sprint, the manual team would focus on testing the new features, while the automation team would focus on running the regression test for features that were developed till the earlier sprint. And by this way, we had a right balance between the manual team with the manual testing and the test automation. So we are at the end of the presentation. I'm just going to quickly talk about the benefits of using this kind of a model. The first benefit is cutting down the overall testing timeline. So if you could look at this the panel here before hypertesting, usually this is what happened. The builds were deployed for testing on a Thursday evening at around 9 p.m. Pretty much nothing happened until the next day morning at 9 a.m. when the testing team comes into work, and then they run a round of smoke test manually. And then if that test passes, then they're going to continue with further regression testing. But if not, um, uh, then they are going to reject the build and go forward, with reporting the failures. But when we had this hyper testing model integrated with, with that took care of the CI/CD side of things, whenever the build was deployed at 9 p.m., then at 9:30 p.m. the automated smoke test pack was triggered, and that test would basically test the end-to-end flows and make sure that there are no blockers. And if there are blockers, then it's going to stop the test and give out the results right to the project team right away. If not, if the test passes, then it's going to kickstart your regression test, a bit of functional, the performance test and the API test and all that. And pretty much all these are going to run in parallel in Sauce Labs. And by the time the testers come to work in the morning, they'll have the test results in front of them. All they have to do is figure out what are those product failures and log defects and take it forward from there. So this really did made use of the night time for running all the different tests in parallel and saved a lot of time in achieving the timeline that we had to make to release the product faster to market. And of course, from the overall value perspective, we did in the end reduce the overall defect leakage to less than 3% from 14 to 20% that we had earlier, to whatever defect that went into production was much lesser than 3%. And we were able to accomplish running the 3,000 tests within a span of 5 days for every sprint. And we also enabled getting the feedback on the build within 30 minutes of the deployment time. And also, the overall testing timeline came down from 60% days to 10% days, which was a huge cut down in terms of effort over a period of time. And the scope was about 15 different applications that were tested end to end, right from the e-commerce platform to the distribution center application to the middleware applications and all that stuff. And in terms of the overall cost savings, it took about $1.2 million in a span of a year to achieve this kind of a benefit for this particular organization. I think that's pretty much I wanted to share with you guys today. Like I said, you could build something like this pretty much from all open source tools that are available in the market. It does provide a lot of value in having an alignment with how the end user looks at your product, with the way that your test strategy is tackling your product as well. All right, and you can shoot your questions. You can ask your questions in the Q&A. And you can also reach me at srinivasan.shankar@aspices.com. All right, I have a couple of questions here. How long did the initial setup take until you were able to deliver valuable feedback? So we actually undertook incremental model. So right from sprint 1, we had our manual testers doing the manual testing. And then whatever test cases that were created as part of manual testing were passed on to the automation team, and they automated that right from sprint 1. So whatever that was created in sprint 1 was tested in sprint 2 through automation. So it was an incremental model, and we were quick to get on delivering value right from the first 2 sprints. The second question is, were you all able to do SOAP UI testing with open source version, or did you need any features of the paid pro version? I believe mostly we did use the free version, but just to be 100% sure, I'll have to quickly check if we did use any paid version. All right. Okay. All right. I think I have one more question. How precisely you connect API test results with UI test? Payment page wasn't visible because of 3 minutes long request. Yeah. So let me make this clear. Um, the testers who actually had to review the API results and the UI results and find the correlation there. Right now, we don't have that feature to automatically analyze and tie different things together. But we do have our test cases for both UI and the API test with tags. So with that particular tag for that feature, whenever all these tests are run, the testers look at the UI tests and then look at the API test together and then correlate them to make sure that they have everything in place to point out exactly where the problem is. So it's not an automated process. The test results are manually reviewed by the testers, the UI and the API part. No, the other question is that did you convert every manual test into automated test or only reduced high risk or required tests? No, we did not convert every manual test. We picked out scenarios that are regression cases that would handle or tackle the critical aspects of the functionality and the test cases that are end-to-end in nature and some of the integration points. So only we picked critical cases or the priority cases as part of the automation pack, and we automated that. And this number, from an overall percentage, should fall somewhere around 60 to 65% of the entire test pack. And another question is, which improvements are you planning for future? So one of the things that we are working in-house, I'm not sure if you noticed this in the presentation, there is a component called stabilize.js. This is a beta version that we are using. So what this basically does is it's going to analyze your object identifiers or locators in your test and make sure that even when those properties of those objects changes in the application, your test script would still be able to identify those changes and still run a successful test. Typically, we have seen that when a new build is deployed, the object properties change, but the object still remains in the system, but some of the properties change, like the name changes or some of the other attributes. So we are working on this stabilize.js, which is a platform to automatically analyze your object locators and compare it with the application and make sure that your script could still run. That is one thing. And we are also in the process of integrating Sauce Lab Screener for the layout testing. So those are the two things that we are planning for the future. I don't have any other questions. If you have further questions, I'll create a channel in the Slack with the same topic, multi-layer test automation. And feel free to ask your questions there. I'd be glad to answer. And I hope this session was useful to everyone. Thank you so much for taking time to attend this. I really appreciate it. Stay safe, everyone.